Hi, this is Atarabi and you are watching AirTube. Today we'll talk about rate of chemical reaction. Rate of reaction or speed of reaction can be defined as the change in amount of reactant or product per unit of time. Like amount of product increased per second or amount of reactant decreased per second. So we can measure the rate of reaction by measuring the mass, concentration or volume. This can be done by plotting a graph of concentration against time. If we want to calculate the average rate of the reaction, we need to pick 2 points in time and calculate the slope of the secant between them. For instantaneous rate, however, we need to draw a tangent on the point and calculate the slope of the tangent. We can compare two or more reactions by measuring their rate. So how can we tell if a reaction is faster than the other? If we draw a graph of two reactions, the more steeper curve will indicate faster reaction. Let's say reaction A and B is producing equal amount of product, but the reaction curve of A is more steeper than reaction B. So reaction A is faster. Now, which factors can make a reaction faster? Factors that affect the rate of reaction are surface area, concentration of reactant, gas pressure, temperature, and catalyst including enzymes. Even if the amount of reactant is same, increasing any of these factors or adding a catalyst will increase the rate of reaction. Now the question is, how can we explain these factors and their effect? We can use the collision theory to explain factors for rate of reaction. The collision theory says that successful reaction happens due to the collision of particles with sufficient energy in proper orientation. So effective collision is required for a successful reaction, and the minimum kinetic energy required for a reaction is called activation energy. The conclusion is that increased frequency of collisions or collisions with more kinetic energy will increase the rate of reaction. Let's look at the impact of surface area. If a solid reactant is broken down into smaller pieces, the rate of reaction increases. Why? Because smaller pieces have larger surface area, as they expose more area for other particles to collide. That means more collisions will happen and there will be more chances of successful collisions, which ultimately increase the rate of reaction. Similar effect is seen for concentration. Increasing concentration will boost the reaction rate. Like in this two reaction, the concentrated solution gives faster reaction and more product, because increasing the concentration will enrich the number of particles in the same volume, which ultimately increase the frequency of collisions. That means the chance of fruitful collision is now higher. So an increase in the concentration of a reactant leads to a higher number of collisions, therefore rise reaction rate. If the reactants are in gaseous state, then applying high pressure will increase the rate of their reaction. This is because increasing the pressure will decrease the volume, which ultimately escalate the concentration, therefore elevate the frequency of collision. Increased frequency of collisions leads to higher chance of fruitful collision. That's why applying pressure increases the rate of reaction. However, if no gaseous reactants are present in reaction, then there will be no impact of pressure on reaction rate. Temperature also affects the reaction rate. An increased temperature boosts the speed of reaction. That's because when we increase the temperature, the kinetic energy of all particles step up. So more particles now have enough energy to overcome the activation energy barrier. This leads to more successful collision. Increased kinetic energy also amplifies the frequency of collisions, but it has minor contribution compared to kinetic energy. Light is an energy, so it can also increase the kinetic energy of particles and have similar effect like temperature. Catalysts affect the reaction in a different way. In an energy profile diagram, we can see that reaction only happens after the reactant crosses the activation energy barrier. Catalysts increase the rate of reaction by helping reactant molecules to break their bond by providing an alternative pathway. In the new pathway, the activation energy is reduced. So more particles now can overcome the new activation energy barrier, which increase the frequency of fruitful collision. This is how catalyst can increase the rate of a reaction to great extent. Let's dig deep into the factors and find why they are increasing rate of reaction. Increasing surface area increase heat area for particles, that is related with the orientation. Increasing concentration actually increase the number of particles in a given volume, therefore increase number of collisions. Rising temperature or light increase the kinetic energy of particles and help them to overcome the activation energy barrier. Applying gas pressure ultimately increase the concentration, therefore frequency of collisions. Catalysts or enzymes, however, do this by providing an alternative pathway. In this new pathway, the activation energy is lower than the previous one. So particles can easily overcome this new barrier and make a successful collision. So temperature is the only factor that is changing the energy of particles. Surface area or gas pressure has nothing to do with energy or number of particles. Similarly, catalyst has nothing to do with the energy or frequency of collisions. We will now compare rate curves of different reactions. Rate curves can be compared by observing their initial rate and amount of product. Here in this graph, there are 4 reactions A, B, C and D. By observing this reaction, we can predict some of their properties related to reaction rate. The initial rate of reaction A and B was same, but they ended with different amount of product. So we can say that they had different amount of reactant, but all other conditions or factors were same. We know the higher the concentration, temperature or surface area, the faster the rate or steeper the gradient. Reaction B and D had same starting amount of reactant, but one of these factors increased the reaction rate of B because they ended with same amount of product but started with different initial rate. Reaction D has least steeper curve, so we can say that reaction D has the lowest rate of reaction. If we compare the amount of product, we will see that reaction C has lowest amount of product according to our graph. This is how we can apply our knowledge of reaction rate to observe different reactions. Okay, that's all for today. Hope you guys enjoyed this video. If you have any question regarding this topic, leave me a comment and I will try to answer. I have also given a practice link in the description below. Go and check if you have mastered the topic. See you later. Take care.